Welcome to solverfy.
So we have to find out the mass of 0.346 mole of zinc. Okay, so before we try to solve part A, we have to know um, the equation that relate number of mole and mass. So for number of moles, so most of the time I would use n, with small letter n. Number of moles is equals to the mass of our substance divided by the molar mass. All right, so this is the equation that you have to know, and every time that we have to know in order to solve for the questions. All right, so we want to find the mass of 0.346 mole of zinc. So we have the number of moles, and then we have the molar mass. We want to find the mass. So if you arrange the equation, just add mass to be a m, short form of mass. So we have the number of moles multiply the molar mass. I will just molar mass m represent molar mass. So we want to find the mass. We just need to use multiply the number of moles times molar mass. So we have 0.346 mole. And the molar mass of zinc you can find from the textbook or from the periodic table. And then it should be equal to 65.41 gram per mole. All right. So it should be MOL instead of MOLE. Okay, so we just need to multiply them together, and then we should be able to find that is equals to 22.6 gram. And this will be the mass of 0.346 mole of zinc. Okay, part B. We have to find the number of fluorine reatom in 2.62 mole of fluorine. Okay, so for part B, we have to know that how to convert number of atom, maybe individual atom. We count 1 atom, 2 atom, 3 atom to moles of atoms. So the conversion factor is that for each number of moles that we have, it will be corresponding to the Avogadro number roughly 6.022 or 6.02 times 10 to the power of 23. For this case, we are looking at the number of atoms, so it will be corresponding to 6.02 times 10 to the power of 23 atoms. Okay, so we just need to find out the total number of mole atoms, and then we can know the moles, and then we convert to actual number of atoms. Okay, so we have 2.62 moles of fluorine molecule. So for in each of the fluorine molecule, they will have 2 fluorine atoms. So we have to multiply the number of moles by 2 in order to find out the actual number of fluorine atom. So times 2, we will have 2.62, 5.24 mole. All right, so and then we are going to apply our um, conversion factor. And we know that for each number of mole, we will have 6.02 times 10 to the power of 23 atoms. So therefore, we are going to multiply our number of moles or actual atoms by the Avogadro number divided by 1 mole. And then we should be able to find that is 3.15 times 10 to the power of 24 atoms. And this is the number of individual fluorine atoms in 2.62 mole of fluorine. That's a lot of atoms. Okay, so the last but not least, we're going to look for how many calcium atom in 28.5 gram of calcium. 28.5 gram of calcium. All right, so we have 28.5 gram of calcium. We just need to find out the number of moles. So number of moles of that, and then we can find out the actual number of atom. Okay, so we want to find the number of mole. We are going to use the equation. Number of mole equals to mass divided by molar mass. So we have our mass of 28.5 gram, and then our molar mass for calcium is 40.408 gram per mole. And then we are going to use our calculator to find out the number of moles. and then it should be equals to 0.711 moles. Okay, so we have that number of mole of calcium. So how about the actual number of calcium atom? Again, you just need to take our number of mole times our Avogadro number. So you 711 moles multiplied by our Avogadro number, 6.02 times 10 to the 23 atoms per mole. And then you can use your calculator again. And it would be equals to 4.28 times 10 to the power 23 atoms. So we have that many of calcium atoms.